Another one, number 3 example. So again, you do not need to write the entire problem. Please don't. It's just more work than you need to. It's already written down for you in the book, whatever problem you're working on. Just consider this as being written in the book. Okay, so a wire is attached to the top of a pole. The pole is 2 feet shorter than the wire, and the distance from the wire on the ground to the bottom of the pole is 9 feet less than the length of the wire. Find the length of the wire and the height of the pole. Well, this sounds like a bunch of gobbledygook that I can't even begin to figure out, right? So be careful. We'll just take it one little step at a time. So the first thing is, I've got this pole sticking up straight in the air like a flagpole, and from the top of it down to the ground is a wire that is stretched. Okay, and I need to find out how high the pole is, and I need to find out how high the wire is. That's all that's really going on here. So, and this is our third example. So we're going to start by drawing a picture and assigning our variables. So it says, a wire is attached to the top of a pole. Well, a pole is going to go straight up, and a pole is on the ground. I'm going to say this is my ground. So here's my pole, and it says there's a wire attached at the top. Okay? Well, then the wire is stretched to the ground. But you notice what I've created here is a triangle, and it's actually a right triangle. Right triangle means that I've got at least one angle in here, right here, that is 90 degrees. Whenever that happens, and nothing in the problem is said about area, then I need to think, okay, I'm trying to find how long this side is, basically, and how long this side is, okay? But it doesn't say anything about area. So then I need to think, because it's a right triangle and I'm looking for sides, the Pythagorean theorem. You remember what that is? Take a second to think about what that is before I write this down. Pause if you have to. So the Pythagorean theorem is a squared plus b squared equals c squared. Now the biggest, c squared. The biggest thing I need to know is where's c. C is our hypotenuse, okay? Well, what that means is wherever my right angle is, I need to draw a line straight across, and that's my hypotenuse. So this is side C. Then it doesn't matter what the others are. I can label them A or B. This can be A. This side can be A or B. This side can be A or B. So I'll just label them A and B like that. Now let's go back and actually assign our variables. A wire is attached to the top of a pole. So I'm going to say let P equal the pole. That makes sense, doesn't it? And I'm going to say let W equal the wire. Okay? Now, the pole is 2 feet shorter. So here is my pole. So pole is means equals, 2 feet shorter. So I'm going to be subtracting 2 than the wire. Oh, so it's W minus 2. That's what my P is. Okay? And the distance, let's look at this in a different color. Let's do this guy. Okay? The distance, okay, down here, from where the wire touches the ground to where the pole is. So this distance here, okay? The distance from the wire on the ground to the bottom of the pole, from the wire on the ground to the bottom of the pole, is 9 feet. Well, this is, we're calling it B, I guess, side B is, okay, 9 feet less. So that's minus 9, but less than what? Then the length of the wire. Well, here's our wire. Okay? Find the length of the wire and the height of the pole. Well, we've got our variables assigned. We've got what P is, we've got what B is, and we've got what W is. Okay, so now we just need to put this into the Pythagorean theorem. So this is our, this is our side A. So that's W minus 2, the quantity squared. Oh, you know what? That's a perfect square trinomial. Perfect square trinomial. And remember, a perfect square trinomial in generic form is x squared plus or minus one of these, not both. Either plus or minus, not both. 2 times x times y plus y squared. That's a good thing to remember. Okay, and then my formula back here, a squared, so this is our a squared, plus b squared. Well, this is my b, so w minus 9, the quantity squared. Oh, look, again, that is a perfect square trinomial. Equals, and our side C we've got as W, and it's squared. All right, now we're ready to go. So here's what I'm going to do. Perfect square trinomial. This is my X, this is my Y. So I'm going to go straight to this. In a perfect square trinomial, my X is squared. So this is my X, so that's W squared. In a perfect square trinomial, this sign is whatever this guy is. So that's minus. Okay, and then my middle term is 2 times x times y. Well, this is my x, this is my y, so I multiply those two together. W times 2 is 2w, and multiply that by 2. So 2 times 2 is 4w. There we go. And then in a perfect square trinomial, this sign is always positive. And then the third term in a perfect square trinomial is y squared, and this is my y, so 2 squared is 4. All of this right here is just this guy, okay? And then I bring the plus down from here, so plus, and now I'm going to do it again. This is my x, this is my y, so into a perfect square trinomial. Remember, I told you I want you to go back and forth. So this is from factored form. We're putting it back into multiplied form directly. So this is my x, which is squared, so w squared minus, because this guy's minus, and then 2 times x times y, so that's w times 9, which is 9w times 2, so that's 18w. And then plus, because in a perfect square trinomial, this sign is always plus. And then my y is 9. So 9 squared is 81. And then equals, because this is all just this. And so then we've got w squared. Well, the next thing I'm going to do here is combine like terms. So let me get rid of, whoops. Just these lines here, because first I want to take all my squared terms just on the left side of the equal sign. First I combine all like terms on each side of the equal sign separately. So between those two, I've got 2w squared, because there's 2 of them. So now I'm done with that. I'll lightly cross them out so I can still see them, but I don't have to look at them anymore. Then I want my next terms that are like terms. So these two go together. So -4 minus 18, add the two numbers and keep the sign. So I know I'm keeping the sign. And 18 plus 4 is 22w. So that's good. Now I'm done with these. And then these are like terms. So add the signs are the same. So add the signs, add the numbers and keep the sign. So the sign's going to be positive. I add 81 plus 4, that makes it 85 equals w squared. Okay, so now I've got a quadratic equation because I've got squareds here. Standard form of a quadratic equation, ax squared plus x plus c equals 0. And now means I need to get it into standard form. So I am going to, because this is squared and this one's squared and this one's positive and it's bigger, I am going to move this guy to the other side. So I'm going to subtract him. So 2w minus 2w squared minus w squared gives me 1w squared. Never write the 1. Minus 22w plus 85 equals 0. Well, now I'm just needing to factor this. So rule number 1, any greatest common factors? Nope. Rule number 2, is it a special factoring form? Not sure about that. First question, is it a binomial? Nope. So it's not a difference of squares. Next question, is it a trinomial? Yep. And this guy is positive, so maybe it's a perfect square trinomial. Let's just do this over here in case it's not. Can I take an even square root of w squared? Right? Yep. And then over here, can I get an even square root of 85? Nope, can't. So we go on to rule 3, and this would be 3a because that's a 1 coefficient. So automatically, double bubble equals 0. Put a w in the first, and 1 times 85 is 85. So 1 and 85, 2 doesn't go into it. 8 plus 5 is 13, so 3 doesn't go into 13. 3 won't go into here either. 4 doesn't go into it. 5 does. 17 times 6 doesn't, 7 doesn't. You go all the way through. These are the only 2. So when I look at this, that's going to be my pair. Minus 5 and a minus 17, I think, is what will work. So I look at these two. Let's do our 2 steps. Add these 2 together. I get negative 22. That's what I want. Last critical step. Negative times a negative is a positive. That's what I want here. So this is good. Just plunk these 2 in here. And now I go w minus 5 equals 0. And w minus 17 equals 0. And solve for this one. And I get w equals 5. W equals 17. Now I've got 2 answers. I need to see what makes sense. So when I take 5 and put it, let's just try here. If I go 5 minus 9, well, that ends up being a negative 4. And a measurement can't be negative 4. So this guy doesn't work. So my W is 17. Okay, so that is how long my wire is. That's what we're looking for here. Wire is 17. That's what I've got. Now I need to know how long the pole is. Well, this is my pole. P equals W minus 2. So let's go down here and go P equals W is 17 minus 2. So P equals 15. Okay, so let's write our answer. And if I have time, I'll check this. So we say the wire is 17 feet long and the pole is 15 feet high. Now, I got 30 seconds. Let's see if I can check this real quick. So, a squared, I need to figure out what this is. So, 17 minus 9 is 8. So, 8 squared plus b squared, that's this one. Oh, this was 15. So 15 squared equals 17 squared. So 8 squared is 64. That's 225. 17 squared is 289. And I think my time is up.